Start with the next talk, which is given by Lakshmi, open source GIS framework for harmonization and updating of functional areas. You have 20 minutes.
Thank you so much. Good afternoon, all. I hope after lunch now. So, yeah, understood. So, my talk name is Open Source GIS Framework for Updating and Harmonizing the Functional Areas. So, everyone know functional areas are nothing but administrative boundaries. Okay. So in the morning panel session, there was a discussion happened, right? But why there is no open data and no open source solutions in government thing? Why government is not promoting? So that is the reason why I will start from my first slide itself, a national geospatial policy. So National Geospatial Policy 2022. So this National Geospatial Policy, especially it's a groundbreaking. It's try to transform whatever the geospatial things that is there previously to a more citizen-centric one. Okay, so here it is National Geospatial Policy itself encourages the open standards and open data and platforms in section 3.6. So section 3.6 of National Geospatial Policy emphasizes open data, open standards and platforms. Okay, so this is the government is also moving towards open data and openness. And it identified 14 national fundamental themes. 14 national fundamental themes in which Survey of India, which is a national mapping agency and nodal mapping agency, which is assigned with a, these 5 fundamental themes. First one is a geodetic reference frame. So this is the datum. And second is an ortho imagery. So it is proposed to acquire 10 centimeter resolution ortho imagery for a whole nation. And elevation is also on 25 centimeter to 50 centimeter, somewhere in 3 meter based on the hill region. Okay, and geographical names, name of each and every city and places. This is called toponymy. And another is a functional area. Functional areas. These are the administrative boundaries. So this particular study is about the how open source technologies can be used in functional areas. So actually previously most of the governments are using COTS, right? So this is an attempt to make it, bring it everything in a FOSS, how to check the feasibility of FOSS for FOSS GIS tools. Okay. I already explained what are functional areas. These are jurisdictions and also districts, village maps. And why they are important, everyone know. They're for governance. And previous workflows are mostly based on COTS. COTS softwares. And they are distributed databases. So everyone working on an individual database, and when you are going to merge it into the one, go for an edge adjustment and remove the errors. That is quite cumbersome and time consuming. If you are going to work with like a nation like India, which is quite huge, right? So this brings us the aim. The aim is to test or develop an open source GIS framework, which is already exists, to check the feasibility whether we can work with the functional areas or not. And in these functional areas, what we did is Survey of India has a course network. Course network is a, right? It is a GPS which gives you real-time coordinates with a 2 centimeter accuracy. So you just need to take the GPS and it will give you 2 centimeter accuracy coordinates. So which is very useful to update the positions in a survey grade level. Okay, so we incorporated the course network into the FOSS using FOSS technology to frame this framework. So let's look into the study area. This study area, we took it as a Gandhinagar district. Gandhinagar district is in, Gandhinagar is the capital of Gujarat. Okay, Gandhinagar is capital of Gujarat. So we took Gandhinagar district as our study area, and being a national map agency, Survey of India receives the data from various stakeholders. For example, state government has their own state government's boundaries, and also different boundaries from forest department, forest boundaries. All these boundaries come together into the same platform and then need to harmonized into a NGRF, National Geodetic Reference Frame. So it should be in the common reference frame. Okay. So this comes to the methodology. What we did is all the data sets we collected from ORGA, municipal, municipal corporation, corporation boundaries, and also state government, village boundaries, and all these are put into the PostGIS database. And there are various projects are going in Survey of India. We have a high resolution images up to 10 centimeter level for most of the acquired under different projects. So all these HRSI images are kept into the one platform in the raster images, and these two are published in GeoServer. Sorry, those errors are, because of Windows to Mac transition, some arrows went wrong, so don't mind that. So what happened is we have published that with us through GeoServer as a WMTS layer, whatever the raster HRS data sets are there, and also WFS for the boundary pillars. Each and every village has a boundary pillars, district boundary pillar, and state boundary pillars. Boundary pillars are the one which is physically exist on the ground. Okay, whereas right, there are 3 steps are there: demarcation, delineation, and delimitation. So delimitation defines the boundary. Delineation, we are going to make a cartographic boundary, and demarcation means we are going to place that on a physical structure. For example, a pillar which is a junction of 3 different villages, that is a demarcation. A pillar exists on the ground. Okay, so that will be, these 2 WFS layers are published and 1 WMTS layer is published. And then what happened, through internet, the server we kept in Pune, and we are working in Gujarat. Okay, so the WFS layers we consumed in QGIS to edit that seamlessly, and the same time with multiple users, with multiple user roles. So someone can check, someone can edit, someone can update, and nobody can delete. So okay, that major deletions are happens. Whenever you are working with a huge data set, deletions happen. So we restricted the deletion, because villages doesn't delete, either they update. So, and then Q field we use it as a field app. Again, sorry for the missing arrows. And we are using that course. Course is a continuous operating reference system. So we combined the course technology by using QGIS, and we started picking the pillar locations within 2 centimeters. I will show you those videos I have. I will show you that. And then once the collection, if any missing pillar is there, that can be located and demarcated and can be updated simultaneously and sync back to the server, the central database. And then we developed a dashboard to display the data by using MapStore. So basically we used PostGIS, GeoServer, QGIS, QField, and MapStore as open source technologies, and Survey of India course, which is also free to public up to Jan 31st. I think it is open for everyone if anyone want to test it and try it. So these are the technologies what we used. And then what happened, GeoServer seems, we also facilitated the offline editing also. If this GeoServer is also in the campus, we can make it as we can directly fetch, instead of going to the GeoServer, directly take the data from the PostGIS itself. So this is the structure. We developed it in a mid-level workstation for our trial. It's a 256 GB RAM and 24 GB GPU. So that's the mid-level workstation. And we connected to a Sophos, and we took a BSNL static line for making an IS static IP. And through static IP, we used Tomcat as a web application server, on which everything was hosted there, means GeoServer and MapStore. And course, QField and QGS, which is a desktop client, field client, and also course as a to collect the boundary pillars. So these are the technologies what we used. And this is a example of PostGIS server. And then these are the hosting of the Geo server and map store. These are the layers for WMS layers. And this is the Cortoset 3 image. And then this is how, we just did fetch the data set to QGIS for editing. There is a topological editing option is there in QGIS. So we use that. So otherwise there will be, gaps will be there, right? So we use that topological editing. And some of the layers we don't need to edit, right? So those layers we took it as a WMS layers, and those we want to edit it, we kept it as a WFS layers. So this is how we did it. We tried that FOSS for functional areas editing in using FOSS technology. So see, this is what happens. Everyone creating their own boundaries, and there are some of the boundaries are notional. The notional boundaries are just boundaries. They they notionally exist. They may not be exactly true on the ground. So then this is a process of delineation. Delineation means we have, right, from the HRSA that boundary should follow a field bund, right? So this was edited to follow the field bund. Okay, so this is how the satellite images which are using NGRF, we are going to rectify it, bring it to the near to the ground. So and I will just this is a course course is a continuous operating reference system. So these are the course stations in India. So you can see they are spread all over India. So this technology we use to collect the pillar. You can see this is a QField application. We use QField to consume course services and to update the WFS layer of a boundary. I can't make. Okay, so this is the accuracy what we got from course and incorporating with the QField, and you can see this horizontal accuracy is 5 centimeter on this spot. So you don't need to wait. You can take the course and you can locate your position within 5 centimeter and with an horizontal accuracy of 6 centimeter. Okay. I already given you the course link here. So course.surveyofindia.gov.in. So where you can register for course services which are free for government institutes and also government universities. It is a free service. You just need to register. And this is a dashboard which is under progress. We try to create it by using MapStore, and so this is the attempt actually to test FOSS in terms of COTS what we have. So instead of COTS, we just explored whether FOSS framework GIS tools can work for multi-user editing and for concurrent boundary delineation through FOSS workflow. And also we tried QField and course integration for survey grade positional reliability to acquire the positions, like for demarcation of the pillars and also for delineation purpose and stakeout purpose. So this is the overall workflow. So that's it. Thank you. So any questions you have, so I can answer. Thank you.
Thank you so much, Lakshmikant. I mean, good to see, Survey of India itself taking the step of everything for